Today I'm going to present data analysis on blood pressure. As we all know, high blood pressure is severe, especially during this pandemic. So, a model to predict blood pressure is related to everyday life and is helpful. To make such a model, I created both a training dataset and testing dataset using analysis dataset. As you can see, the datasets include many variables, and each variable has a special meaning and is in a group. Now, I will talk about methods. I use a linear regression to build the design model, but before it, I did a social check. I found some nonsense laws. High-income people had low poverty, saying they were very poor. I decided to drop these roles, considering the possibility of writing the wrong numbers during the survey. Then, I did diagnostics on the full model to see if we should consider all the variables into account. From scatter plots, I didn't observe strong evidence of nonlinearity. From these four plots, they enhance our confidence that we should consider the full model. For example, QQ plot is almost a straight line except for the very last part, and no distinct patterns in residual plot. But outliers do exist. I decided to keep them for the sake of variability, but I will talk more about it later. Also, to keep a lower variance in the model and stability, I removed some variables based on their VIF value. Then I started regression. First, I did a simple regression on smoke now. A significant effect was observed, indicating people who currently smoke have lower blood pressure. However, this simple model is pretty bad. The MSE is also large. To make a better model, I used some machine learning approaches, AIC, BIC, lasso, and ridge. And this is the result of AIC. The cross validation part looks good. This is the result of BIC. The cross validation is good, except the last part. And the mean square error is lower. And this is the result of lasso. The mean square error is slightly higher than that of BIC, but it has only one variable. This is a result of a bridge. Even though the cross validation plot doesn't look too bad, but it has the largest MSE among our methods, and it has many variables as well. Probably will cause some overfitting issue. Here's the results. I'm going to make judgment based on the following rules. As you can see, Neural BIC has the lowest mean square error. Lasso has two fewer variables. Therefore, I decided to use the Lasso model. I also did diagnostics on the final model. I tried to see if removing outliers helped. It turned out that by removing outliers, mean square error remained similar, but the cross validation became much worse. Now, let's discuss the final model. The prediction formula tells that by growing up 1 year older, we are likely to have increase of 0.4 in the blood pressure reading. Notice that the smoke now is not included in the final model. It shows that although the impact of smoke now is significant, smoke now is not predictive enough. The MSE is just around 16 offset from real value, which is not bad. Even use a pressure measure, we can still see different results from time to time. However, my study has some limitations. For example, I didn't look into how outliers could affect the regression, but from my attempt to remove outliers first, I did get a different final model. Also, I didn't do diagnostics with categorical variables. At last, I want to talk about a potential new way I came up with during the study. Since the variables are grouped, maybe we can select a representative of each group and use this representative variable to build a model that combines all the features of groups. Maybe it can make a better model. That's all. I thank you very much for watching.